Hey guys, Mr. Cram here. If you've been paying attention to the news lately, you've probably heard about this chemical DHMO. It's getting a lot of publicity. It's a real nasty thing. If you look at it here, the dangers are death by inhalation, it corrodes metals, causes tissue damage and burns, lots of different dangers associated with it. Where is it used? It's used in nuclear power plants, it's used in chemical warfare, animal research, torture, lots of nasty things. And then finally, where do you find it? Lots of places. You can find it in tumors, you can find it in prisons and hospitals, and lakes and streams. Seems like it's all over the place, right? So if you look at the bottom there, you can see its actual name is dihydrogen monoxide. That's the name of the abbreviated DHMO. So it sounds like pretty nasty stuff, right? You think we should do something about this? Or you think that the society is right for wanting to get rid of this chemical? Well, if you know your chemistry, you know that this is totally bogus and this doesn't make sense. Because chemistry uses names like dihydrogen monoxide to mean certain chemicals. Okay, we've probably heard of things like this. But if you know your chemistry, you know dihydrogen means H2, that's dihydrogen, and then monoxide is mono, one oxide, 1O, H2O. So this is something we need to be aware of, right? Many times people try and say these names of these chemicals that sound long and scary, but we just need to be able to understand exactly what they're talking about when we hear these names, these chemical names. So this is really important, guys. You need to know that chemistry has its own language. Okay, we need to be fluent in this language. We need to know how to take something like methane reacts with oxygen gas to produce carbon dioxide and dihydrogen monoxide, and know what they're talking about. We need to know that it's this equation here below. We need to know the symbols for those words. So we're going to talk about that today, and that's what this video is about. So quick background, a reminder, binary compounds. Okay, there are two types that we'll talk about. We'll talk about covalent and ionic. Quick review, covalent compounds are going to contain two non-metal elements. Okay, non-metals are going to be the elements here that are the blue ones. Okay, so there are a lot less non-metals than metals. The red ones are going to be metals. We'll not really use this classification of metalloids, but you should be aware that there's this divider, okay, this step that goes down. It's the bold black line here that kind of cuts all the metals to the left and then the nonmetals to the right. Okay, so covalent compounds are going to contain two nonmetals. So something like nitrogen and oxygen bound together, that would be considered a covalent compound, where an ionic compound contains a metal and a nonmetal. So something like calcium combined with oxygen, that would be an example of an ionic. All right, so how do we name these covalent compounds from a formula? So you're looking at a formula, you want to say its name properly, right? So the first thing you want to do, we're talking about covalent here, so you should know that we're dealing with two nonmetals. We want to write the very first element in that formula, how it is spelled on the periodic table. So here's an example. CF4 is going to contain the very first element of carbon. That's what C is. So we just write the name carbon. Step 2, we're going to add a prefix. So that's before the word carbon to indicate how many carbon atoms are present. If there's only one, we don't need a prefix for that very first element. So if you look again, CF4, there's only one carbon, right? So we're not going to put any prefix on carbon, we're just going to call it carbon. Step 3, we're going to write the name of the second element, which in our case is F, or fluorine. That's how you would pronounce it on the finding it on the periodic table. We are going to change the ending though for the second element. So you only do this for the second element in a compound. So fluorine, INE, becomes fluoride. Many of these elements that we change, they will have that INE ending, so that's what you're chopping off and replacing with the IDE. Not all of them, but a lot of them. Step 5, we're going to add a prefix, so that's before the word fluoride to indicate how many fluorine elements are present in the compound. Again, if you look at the formula, CF4, there are 4, so we need a word to represent 4, and that's what the tetra does here in the name. So we get tetrafluoride. Step 6, we're going to put together step 2 and 5. So what was the name of the first element, and what's the new name of the second element? So CF4 becomes carbon tetrafluoride. And that's how you do it for all covalent or non-metal plus a non-metal binary compounds. So you always just name the first element, whatever it is on the periodic table, and then you make the most changes to that second element. You need to know these prefixes. So these are the prefixes to represent how many you have of any element. So mono is 1, di, 2, tri. You've probably heard many of these before. You got to know them cold, okay? So make sure to maybe take some notes on that. Flashcards, do something to know these prefixes, okay? Oxygen's kind of a weirdo. He doesn't fly by all the rules. So make sure you understand oxygen. He doesn't have that INE ending. So what you might guess, maybe we just drop the EN. You actually drop this YGEN and make it oxide. You've probably heard that before, so it makes sense. So prefixes that end with an A or an O, we actually drop that final A or O in the prefix name and then stick it on the oxide. So let's look at some examples. Okay, so 1, oxygen, monoxide. You might guess that there would be another O there because there's an O in oxide, and mono is the correct prefix, right? So you might guess it would be like this. I don't know why, but they decided that looks too weird, so we don't do it, okay? So we drop the O and we just make it monoxide. So tetra, which we saw for CF4, becomes tetroxide. We don't write tetraoxide. Hexoxide, not hexaoxide. So anything with an A or an O. There are only 2 other prefixes that don't have A's or O's. That's di and tri. Here we do have double vowels. We have an I and an O. Those are the only ones that are just the normal rules. So all the other prefixes we change.